Gentlemen, welcome back to Good Enough Garage. On today's episode titled Life Gets in the Way, we add a safety box to the VW custom wiring harness fuse block thingy before we have to run and pick up the kids. So first I want to level set a bit and go over some housekeeping. We shifted the bench power supply from this side to this side. I kind of want to show a flow of input to output this way from left to right. So what we have here, first of all, nothing has changed. We have two hot leads. One goes simply to the ignition, and then later it feeds part of the fuse block. And then the second hot lead goes to the fuse block. But as you can see, we've now color coded. I want to make a distinction that this entire fuse block isn't linked. This is just three fuse blocks physically connected together, but they are separated if we were to look at the back in terms of electrical connections. And nothing says uh, what the fuse block actually does and how it's wired, like a red light, yellow light, green light, go. So red wire, permanent power, yellow ignition power, and green is only the top single fuse on here, the start fuse, the run fuse, if you will, for when we turn the ignition momentarily to the start position and it springs back. So we know that the other three are really like these middle yellow ones. But this is just to remind us that they're not all the same, okay? So that's where we're at. I kind of made room here. We're going to have a laptop here. And we're going to go a bit further in this video with the safety box than we did in the prior one. A couple videos back, we interrogated this box using CAN bus, which is sort of a protocol. It's a way of car components talking to each other. And we went as far as giving it power and then having the zombie make it click, okay? So the clicking meant the contactors are opening and closing, but that was kind of as far as we went. That's all we wanted to do. Well, today we go a step further. Okay, EV converters, let's take care of the hardware first before we move on to the laptop and the software. So we're going to start off by using the stock OEM harness for the safety box here. So this part is stock, and in here we have two red wires which we need to get 12 volts from the fuse block ignition on. There's a black wire which is our ground, and there's this yellow wire and purple wire twisted together, twisted pair, which is our CAN bus for communication. So while these wires will power our intelligence inside the safety box, these wires will control it. And we're doing what is called as the low voltage wiring right now. This safety box gets big fat orange wires in here or cables in here that carry the high voltage and the high current, but we're doing the low voltage part at this time. So let me see if I can plug this in and not look silly, and I always do it backwards. It's like guaranteed. So hopefully you guys can see this. So that clicks in there. That's stock, nothing's changed. I'm just gonna move it to the side here. And now let's grab the black wire, and the black wire just has a ring terminal here, and that is going to run to our car battery. So this bench power supply, think of it as a car battery. And again, instead of alligator clips, we use, oh, come on, fine threads, my favorite. We use the studs now. I'm going to try to maybe make it a little bit more presentable and untangle this mess if I can. And I might just run it like back here for some crazy reason and then look for it later and not be able to find it. Okay, so I'm just wiring up black negative wire to the bench power supply. It goes to the same stud that the ground black wire from the VCU runs to. So now our negative stud on the bench power supply, you guys can see that, just has 2 wires on it. All right. Nothing gets added to the positive stud because we're tapping in through the fuse block. So now we take these 2 red wires and I join them together. So something I want to share with you guys, don't mind that I have this fuse. So I'm gonna be adding a fuse here. There's an inline fuse, and the only reason for it is because I have a different wiring harness for my coffee table presentations and a different wiring harness here. One, I just use regular inline fuses and buttons, whereas here we're using the ignition. So I just did this to make my life easier. And this is why I like these inlines, because look, they separate like this, and I can use a different one now. I can put a different connection. So while this one will be plugging into the fuse block, so my other one is the same thing, except it has a different end on it, so I can put it on a battery positive terminal on a coffee table. So this is what I was talking about, how I like these inline connectors, because they can also work as a disconnect, right? And I'm also excited to share with you that this is how I used to buy them. I used to buy them pre-manufactured, and there's a couple limitations here. These wires are really thin gauge, light gauge. And I don't know why electricians called wire gauges light and heavy. It has like nothing to do with that type of measurement. But that's just my silly brain. But these are probably like 22 gauge, very skinny. You're also limited to the color. We're only getting red. So I managed to find them in these little packets. And this is a bigger connector, so it will accommodate heavier gauge, okay? And it allows us to use wires of whatever color we want now. Same thing on screws. And this one takes the full-size fuse. So here we can actually use a full-size fuse rather than that little midget, right? And it took me a while to find these, and this is why I'm sharing with you guys. So there's springs inside of that thing, but more importantly, there's these little terminals. And I had no idea what they were called, and they're called buttons. So I think they're like called inline fuse buttons, and they get crimped on to the end of the wires. I know I'm doing a tangent, but I like this kind of stuff, and whatever you can do to make your life easier. See how that's crimped on? And some I will actually even heat shrink in there. And I told you, oh, we can use different colors, and here I am, and I built another red one, but you get what I'm saying. Where is the other one at? Did it already walk away? Okay, yeah, so same thing, right? I've built 2 of them now, made, whatever. And they're just different connections on the other ends for your convenience. So I really like that. That's kind of cool. I will share with you the part number. These are off of AliExpress. I don't know, man. I'm kind of liking that website. I know all you electrical hobbyist guys, engineers, what have you, probably have known about AliExpress forever, and I'm just discovering it. So you're on there, oh, $2, $3, $1, $2, $3. $90 later, you place your order. You know what I'm saying? Okay. So back to this, just ignore that there's an inline fuse. There won't be in the car. The noise you're hearing is my solar panel inverter fan kicking on, of course, as I'm making the video. If I was in here just like sweeping, mopping the floor, it would never kick in. It would just be fine. Okay, so the power to the safety box has to go through our fuse ignition on. So this is permanent power. The first one on here is the VCU permanent power, so that it sits in standby mode, not really on. It just wait in the waiting. The middle here is ignition on, and so we have the first one is the ignition on lead on pin 15 to the VCU. The second one is our shift button, which, oh, you guys can barely see it, is down here, zip tied. You know me, I love zip ties. Never miss an opportunity to use a zip tie. I am deliberately not including the forward and the reverse wires in the VCU at this stage, just to keep it less cluttered. We're not focusing on that. We know they go on pin 53 and 54. So I'm not going to include them in this demo. Just I want to only focus on the part we're actually testing and implementing here. So I hope you guys understand and follow that logic. And then we need to put that in the third position. I'm going to take off my glasses so I try to do this correctly. You know me, I'm a click junkie. I want to hear you click. Ah, yes. Okay, so we have set up our third position, third fuse here, third fuse down. It's going to also get a 1 amp. All of these get a 1 amp. If they blow it, then we're going to go to a 2 amp. So let me get a 1 amp fuse. So I think that says 25. They came in off of Amazon. I bought a bunch of them just in case. You can't find 1 amperes like in auto parts stores. You know, that's just too low for regular automobile stuff, I guess. So I order them online. Okay. I know you love making me look bad on camera, so I'm just putting a fuse in. Why so difficult? Oh, come on. Okay. That was easy. All right, so we just added it. It is all clicked in there. All right, so safety box will now have its power. Moving on, now we grab the twisted pair, and we have this yellow and a purple wire, if you will, and those go right above our permanent power wires, and the yellow is on pin 28. I think that's CAN high, and right next to it on pin 27 is CAN low. CAN bus uses 2 signals. There is such thing as a single wire CAN, so we may implement that in something later on. So, you know, I mean, somebody said, whoa, 2 wire CAN? Bro, that's too many wires. I can do it on 1 wire. Cool stuff. So that is connected, and that takes care of our low voltage wiring. But at this time, if we were to power stuff on, we would hear a click. So actually we can test for that. So maybe we should try it. So thank you, my solar panel inverter turned off. So let's quickly try this. So ignition on. And I'm going to try to click this to the start, and hopefully we can hear that box. Oh, we did. I don't know if you guys can hear it, but I sure can. Let me turn it off, and we should hear the contactors open. Oh, it's working. That's great. But all right, so maybe instead of laptop, we can have another way of testing this. So let me show you what I wanted to do. Okay, so here's the neat thing about bench power supplies and what we can do with the safety box. Literally for safety, we don't have to connect 350 volts to this thing to test it. That's just a switch. It's going to switch whatever we give it on and off. So what I'm going to do here is I'm going to plug in this bench power supply. I like using this one to simulate my high voltage. Hopefully that is in the shot. So I use this guy because this one goes up to 60 volts. That one's only 30 volts. Same watts, but it's just higher voltage. So what I'm going to do here, I'm just going to turn it on, and it wants to already pump out 60 volts because it's on max volts. We're regulating or setting the voltage. We're not regulating the amps on it, which is exactly what we want. Okay, so here's what we do. We take these leads and we connect them to where the battery modules would connect to the safety box. And I believe those are on the inside. So the way I remember this is we want the input to go into the safety box. The input is from the batteries to the box. So input inside, output outside. So then we just have to remember which one's positive, which one's negative. And when I look at this thing, I'm never too proud to label, even if it's ugly Sharpie. Okay, so plus and minus, also plus and minus here. All right, so these are a little bit tricky to connect, but let me give it a shot. I hadn't kind of figured out how to slip them on there. Maybe that will work. And positive here. Sometimes I need to take this conduit off. Okay, so this is safe because, like kind of up to 60 volts, plus it's turned off, but up to 60 volts, knuckleheads can play with that kind of stuff and not get dead. Okay, so now we have power going into it. Okay, if we had a laptop, we could already measure and sense that, and we'll do that in a later part. But without a laptop, let me show you what else we can do. Okay, so here is our motor. This is going to be, pretend that it's a motor or our inverter, if you will. So we're going to connect that now to the output one. So I just got to make sure I get these right, and it's written on there. And it's kind of opposite. So if this was a positive one, its neighbor is going to be the negative. So if this is positive, that's negative. If this is negative, then the output is positive. And they are labeled, but it's kind of like embossed black on black. So let's see if we can connect these. Get in there, dude. Come on, just somehow get in there. Okay, that's maybe okay-ish. Maybe that's okay-ish. Okay, maybe those are holding on there. Okay. How's that for sketchy? All right, so here we go. We're going to turn on our car battery. The ignition is off, I just checked. Now we are going to turn on our big battery pack. So this is just simulating battery pack. You wouldn't turn on your battery pack like this. So I'm just doing it because I'm using a bench power supply. But this and the leads to the safety box are hot. They're always live, if you will. And so that's why the safety box is in the box of the battery pack close to the battery modules, because these leads are hot going into the box, right? You don't want to touch these if you're doing this with the actual battery pack. If we talk about batteries for a second, I kind of look at them in three measurements. So there's the battery pack, which can be called a battery box. That's the biggest thing you can have. That's the big metal silver thing that's so big you can't pick it up. Inside of that, you have battery modules, and those are, I equate those to like car batteries. So my battery pack from the 330E that's going in the Rabbit has 5 car batteries inside it, so 5 modules. And then the modules are made up of cells. So that's a smallest unit that I go to, and it's probably the smallest one you can go to. And I think there's 16 cells per module. And sometimes you hear terms like 96S or something like that. So whatever 16 times 5 is how many cells I'm running. And some guys talk on a cell level, cellular level, that to me is kind of incomprehensible, right? Because it's not practical. I'm happy if I can get it at the pack level, right? Like my pack is 7 kilowatt hours. The one in my truck is 9 kilowatt hours. And I charge my truck to 393 volts. Okay, the big picture, right? Well, they talk about cell level and they'll say something like, oh, I charge my pack to 4.3 volts, but they're talking about per cell. We're both talking about the same thing. It's just like 10 blind guys describing an elephant. You know that whole comic meme thing? If you send 10 blind people to touch an elephant, one will come back and touch its tail and say, oh, it's like a snake. And the other one will touch its leg and be like, it's like a tree trunk. And the other one will poke itself on its tusk and be like, oh, it's sharp like a spear. But they're still talking about the same elephant. How's that for an awesome tangent? Okay, well, shut up and run the test. So we are all wired up. Now watch what happens in addition to a click, hopefully. Ignition on. Start. Check that out. The contactors close. Now, what happened here, I think, is that first, negative contactor closed, and simultaneously, the pre-charge relay closed, trickled some electricity out to that light bulb, but it's so fast. And then it closed the positive contactor because our settings right now, I think, are at 0 volts. So we'll bust out the laptop and dive deeper. But how cool is this, man? We are simulating a high voltage battery pack with this bench power supply. And I had a problem preparing for this. Yeah, actually, for one video, I tried to prepare and fell on my face. I had an issue with this bench power supply. And I'm sharing this because these are cheapos, right? This one says it's supposed to go to 60 volts. It says 61, right? This one, it's at 13.2 volts, but is that really 13.2? If I hooked up a expensive volt a multimeter to it, would it be 13.2 or 13.6, right? So I'm sharing this with you because it kind of pays to have two of everything if you can, and these are pretty cheap. Because if something's kind of sketchy and you don't really feel like it's jiving, swap things around and see what this one's doing or what's that one's doing. But yeah, I have these two, and just getting into using bench power supplies, and I like them. Not only can you preset what they're going to feed out, but what I really like is that they show you they have current sensors in them. So essentially they have like baby ISA shunts in them or a baby safety box shunts in them. And watch, we'll see, and later we can compare. So these, will this one show us that? Let's check. I just noticed that, oh man, I just noticed that this one doesn't show me power. It's just volts and amps. But that one, if you can see it at the corner of your eye, this one actually shows me power, shows me watts. That is interesting. I never knew that about this one. See, I'm still learning even my own junk. So I was hoping that, I don't know if there's a toggle switch on here. I don't see it. But if buying one, get one that has 3 levels of numbers. So it will be volts, amps, and watts. Because I wanted to see how many watts this 300 watt thing is taking. Now, you don't have to be a genius to figure out that this is essentially 60 times 2, about 120 watts is what this thing is pulling right now. But I still like digital displays, and I like to actually just look at it and not have to think. But yeah, so this one, I mean, it still has a current shunt. It just only shows us amps, doesn't show us watts. This one actually shows us the watts, does the math for us. But that's what I like about them, in addition to presetting the volts or presetting the amps, is that we can see what it's, how much power it's using. So this one's using 17 watts because it's really powering a bunch of dinky electronic stuff. but this one is our workhorse. It's actually feeding the light bulb. So I'm excited. I love doing stuff like this and learning and figuring it out and building up your knowledge, one puzzle piece at a time. So in the last part of the video, we'll bust out a laptop and geek out with some software. All right, guys, it's time to geek out with the software. So we're going to start from scratch. So I am going to turn on the bench power supply that supplies low voltage to all of our electronics. This is the car battery, so this would normally be on, right? Because this is a test environment, obviously I turn them off, okay? But this is a car battery, okay? 13.2 volts, the car battery is on, and this keeps our zombie verter in standby mode. I know I sound like a broken record. Okay, at this point, our network is being advertised, Fairy Link. It asks us to disconnect, which tells us it's connected. We fire up the zombie web interface and we jump to spot values, okay? Here we are in spot values. Just want to make sure that the ignition key is off. You guys can see that at the corner of your eye, okay? What we're going to do now is we're going to click on auto and start the refresh. So now the refresh is cycling. I'm also going to turn on something new for us, the battery pack. This is the high voltage battery pack. So this bench power supply simulates that. Again, this would always be on, okay, because this is a test setup. I have to turn on my apparatus, if you will, but this is just simulating high voltage. For us, high voltage is 60 volts. All right, so car battery, battery pack. The light bulb isn't on. It's not supposed to be on yet. Ignition is off. So we just walked into the garage and this is how our car is sitting. If we were to bring our laptop with us, sit in the passenger seat and look at this stuff, okay, operation mode is off. We got our version, whatever, and everything on here is either off or none or zero. I want to show you guys something, okay? So when we just turn the key to on, watch what happens. When we turn the key to on, the UDC2 shows us 61 volts, which matches our bench power supply that's simulating our battery pack. Okay, so we haven't started the car. We just turned the ignition key to on, and that is already reading a voltage. So first of all, what is UDC2? All right, where is that coming from? Damien tells us that the UDC, which is actually UDC1, UDC2, and UDC3 correlate with the good old ISA shunt. And I want to thank Tom, and I think it was Rob from Open Inverter for teaching me this and telling me that this is where these settings come from. And sure enough, I went and rewatched Damien's video and he talks about it as well. So thank you guys. I appreciate the help. And point is, sometimes you have to watch Damien's videos multiple times to really absorb everything in there. They're just so rich with information.
As promised, folks, some funny cat videos for you. Finally, after, I don't know, coming up on 15 years, I finally make a funny cat video for you. Oh wow, oh they've gone crazy. So they've been eating me out of house and home here for the last few weeks. They arrived just before Christmas. So yeah, we've got new workforce here. So I'm hoping that these guys will have some better software skills than me anyway.
So you guys probably won't be able to read this, but this is U1, U2, U3, okay? So since physics took V for velocity already, supposedly we have to use U for voltage, UDC1, UDC2, UDC3, from right to left for some reason. So, okay, well, great, man. Those correlate to the ISA. How does that help me? Well, first of all, we start with process of elimination. So if you don't have an ISA shunt, like I do not, I'm using a safety box. So right away, UDC3 goes out the window. My UDC3 will always be 0 and it will never change because I'm just not using a current shunt with 3 voltage sensors. The one in the safety box has 2. So there's something called UDC and UDC2. We're going to start with UDC2 because it just so happens that that is the voltage reading of the inside of the safety box. That is as if we put the multimeter directly on our battery, okay? Forget the contactors exist. We just tore the battery pack open, put our multimeter right on the leads to the modules, and that's what it would read. And I will show you here, I'm going to turn the knob about halfway. I'm turning the knob on our bench power supply, which is simulating our high voltage battery pack, and I turn it down to 33.5, and it changed UDC to 33.6, let's say. Okay, that's as close as we're going to get. At this stage of the game, our contactors are open. And open and close is a bit confusing. So I'm going to say open means off and close means on. So the light bulb is off because our safety box is currently turned off. Yet the zombie is reading the voltage on the inside of the safety box of our battery pack. Okay, I'm going to turn this back up, and it's reading our full voltage at this time. We haven't changed any parameters. All we did is we turn the key to the ignition on position. So me being so stuck on the up mode right now, still saying off instead of on. I wish it said on. Now I know that if I have some sort of a high voltage battery pack connected, or if I'm simulating it, seeing a value in UDC2 will tell me that my ignition must be on. So this is some sort of a flag for me, and I'm happy to see it. As you can see, some things are flashing here, and I think that's just how it is. Like sometimes there's this tiny little value in UDC. We'll get to that, but don't worry about that part. That's all fine. We'll cover all this. So now watch what happens where we actually turn the key further to the start position. So first of all, as far as what we can see here as humans, is we see that the light bulb went on. We heard a click in the safety box. The contactors are now closed. Closed meaning they're making contact, or another way of saying it is they are on. The safety box is now turned the battery pack on. It is now releasing electricity out of it, okay? So now we're feeding electricity into the inverter, which will pass it on to the motor. And now we see a value in UDC, which I would call UDC1. So this is the voltage past the contactors. This is voltage after the contactors have been closed, okay? And if we look further down on the page, we can see that we are now getting IDC. IDC is physics talk for current. I means current. And so I think it's intensity is how we Americans may be interpreting that. The unit is A for amp, so that's a dead giveaway. And above that, essentially watts, right? Well, kilowatts is power, okay? So now we're getting a reading of what's coming out. Yeah, 1.78 on the screen versus 1.83. You're not going to get perfect measurements. You know, I think my equipment is cheapo, So this is close enough for me. But now we're seeing more parameters reporting on the screen is what I'm trying to demonstrate. Now we're going to turn off the ignition. So this is an interesting behavior here, okay? Because our up mode went to off, but these values did not zero out. And this to me is a bit concerning, okay? Notice our refresh is still going. We can actually stop it and manually run some refreshes. And notice right now that what's concerning me is that the post contactor voltage is still showing a value. This should be 0 now. And below that, power is still showing a value. That should be 0. And below that, current, IDC, is still showing a value, and that should be 0. They erase once I go to ignition on again. So let me do that. Oops, I forgot my auto refresh. And here we go, they zeroed out. So unless I'm missing something, I think when we turn the ignition off, those values should zero out. Okay, let's cover one more thing. I'm going to once again turn off the ignition. Let's go to parameters, and let's go look at our parameter, our pre-charge parameter under contactors. So this battery voltage switch, if you will, no longer needs to be 0 because we actually have a battery now. We can provide some sort of voltage. So to test that theory, let's just start off by setting it to 1. So something's been pointing out to me is that I need to turn off auto refresh in order to make changes in this interface. Makes sense. I can't believe I was such a dumbo. So we're going to say just 1. Hit enter. Go to commands. Save parameters. You know me, I'm doubting Thomas, so I'm going to click on parameters, make sure it wrote it, and it did. I'm just going to clear it for funsies. Okay, so this would have prevented us from starting before. But let's see what happens now. So let's go to spot values, enable auto refresh, and click restart. Without the battery, high voltage battery pack, this would not go to run mode. So let's see what happens. We just went into ignition on. We can tell ignition is on because we get a UDC2 volt reading, okay? This is our little cheat. This is a way for us to cheat. Okay, now we're going to click on run. And look at that. Now it works. So this is pretty unimpressive. So we're going to turn this off. And we're going to do one more test. We're going to go back to parameters. Turn off the auto refresh. Under parameters, we're going to go to, again, to our contactor settings. And our simulation can go up to 60 volts. So we're going to say 40. Hit enter. Go to commands. Say save parameters. Jump to parameters to see if it actually wrote. Yes, it did. So we're just going to clear it for funsies. We're going to go to spot values, enable auto refresh, start the refresh, and without changing anything, our battery pack is still putting out 60 volts. Now we're going to turn on the ignition. And we're going to start it. Pre-charge failed. That is interesting. I did not expect that. Why did our pre-charge fail when all we want to do is pre-charge to 40 volts? Did we mess something up? Contactor is set at 40. Let me try that again. So let's go to spot values. I'm going to turn it off. I'm going to turn on the ignition. I'm going to go to start once more. And it shuts off. I don't understand why that is. I think it should stay on. The only thing I can think of is maybe it has something to do with our light bulb. So I'm going to unhook the light bulb. I'm going to turn off our ignition. I'm going to turn the ignition back on. Go to start. And we went into run. So this is really interesting. I'm wondering if the light bulb is draining it sort of below that threshold. I'm going to need to get some explanations for this. But without the light bulb being a load, it actually now will complete the pre-charge and go into run even with our contactor set to 40 volts. So guys, comment in the comments. Tell me what is happening here. Why won't we complete the pre-charge with my light bulb? I mean, isn't that similar to having a inverter with a capacitor on there and the motor? I'm confused. But I hope I showed you a bit more today and we've gone further. We accomplished our goal of adding the safety box to our fuse block. That was our goal. We've accomplished it and then some. Thanks for watching, guys.